That looks like what we got going on. Compressor's overheated. Need to cool it down, charge it up. So go ahead and pull the disconnect. Go ahead and discharge the cap. Holding only the insulated portion of the screwdriver. And just make sure all our wiring's okay. And now we're ready to charge the unit. This one was just a bit low on Freon, which is contributing to the wiring problem. So we've got my gauges here. I'm going to go T1 to the low side over there, T2 to the high side over here. And now we'll hook up our gauges, and I'm going to put some gloves on to prevent frostbite. It's always safer, always a good idea. You never know what you might run into out there. And I'll go ahead and fire the gauges up too. Okay, gauges are turned on. I want to make sure both of our valves are off, and they are. And we'll also want to make sure all of our lines are sealed below, and those are. There we go. Get my gloves on. I like to use 2 pairs of these disposable gloves. A little bit cooler out today. Nice day, so good day for this. Just get my gloves on here. Now we're going to hook up our gauges. Pull these. And this one wasn't very low on Freon, it was just a tiny bit low on Freon. It actually seemed not like it has a leak, but more like it had a mischarge. Someone didn't charge it enough. So everything feels okay there. Check the high side. Feels okay there, and we've got our O-rings and our caps, and that's good. Okay, so now we'll hook up our high and our low side. There's our high side. You can probably start to see it change on the reading of the S-man. Now the low side here. And same thing, you can watch the S-man change my reading there as I hook up the low side. And you can hear it also. Okay, and without the pressures, without the machine running, the pressures are pretty much equalized. And I'll go ahead and hook up the service line to my can of refrigerant. Tight. We'll open that line. Now we're ready to purge all 3 lines. So here goes. Let's start with the center port. That's our refrigerant. Here's the low side and the high side. Okay. Now we're ready to turn the system on and charge. Make sure all our connections worked here. Worked out good. And we're ready to charge. Okay. So now I'll plug in the disconnect. Make sure everything runs and charge it up. Open the line. I knew this one was a little low on Freon. Ready? Capillary tube system, so we're going to be charging according to subcool. Sorry, we're going to be charging according to superheat. With the TXV, you want to charge according to subcool. Capillary tube or a fixed orifice system, you want to charge according to superheat. For about 8 to 15 degrees superheat. Seems like we're low on Freon on the low side. Look for the PSI. And see we're high on the superheat. We're getting subcool at about 5.1. Definitely low on Freon. Okay, and pause string. Pressure's not too hot yet. So if you're using traditional gauges, you'll be wanting to look at the green dial on both sides, on the low side and the high side. On the green dial on the high side, you're really looking for ambient plus 30 is a good rule of thumb. No, it's not as precise as checking superheat. You're looking for 18 to 15 degrees superheat. On the low side, that's going to tell you superheat. Superheat's calculated by figuring the saturation temperature at the coil, which is usually 40 degrees, 40 to 45 degrees, somewhere in there. Subtracting that temperature, and that's going to be indicative on your low side line on the green dial for R22. So you're going to take that temperature on the green dial on the low side, and then you're going to measure the temperature of your suction line just beyond your service port. It's usually about a little ways from the compressor, but it's just at the suction port there. You subtract that temperature from, you're going to to subtract the temperature of the coil, usually about 40 to 45, from the temperature of the suction line to get your superheat. So if your coil is at 40 degrees and you're at 55 degrees on your suction line, you've got 15 degrees of superheat. You're good. If your coil's 45 degrees and you've got 60 degrees on your suction line, then you're good. You're at 15 degrees. You want to see a little bit of subcool. It just tells you that you're getting refrigerant to the high side. You don't have a fog or anything like that. Or restriction in the line. Anyway, I'll go ahead and move this over to our superheat. And we'll turn the line off and get a reading of where we're at. On the high side, you're looking for your ambient outside temperature plus 30 on the green dial. And you know, it's a good rule of thumb. Tell you whether you're in good parameters. Getting pretty good here, getting close here. If I feel the suction line starting to feel nice and chilly. I can feel it right here. Getting nice and chilly, that's good. Anyway, this will keep the system running good, keep it from running under a burden. That's when you get your burn wires and all that. The system's having to work too hard. Cold water on the compressor just to keep it cooled off, help it charge faster. Looking pretty good here. Good, turn it off. When we turn the gauges off, that gives us an accurate measure. I'm going to call that good there. Our line's nice and chilly. We're getting 9.3 degrees superheat, 14 degrees subcool. We're good there. Okay, so now I'm going to go ahead and turn off my can of refrigerant. And I'm going to disconnect the high side line. And you want to wear safety glasses. Gloves here. Okay, so now what we're going to want to do is move all that refrigerant, the liquid refrigerant that's trapped in that run hose. We don't want to release that into the atmosphere. We want to move it over into the low side. So what we want to do here is open the high side all the way. We've got our low side turned off. And then on the low side we want to open the line a little bit and then close it off. Close it off. We want to do this until our pressure is balanced. Listen into the compressor, making sure it's not getting overworked. We're just drawing that high side refrigerant over into the compressor instead of leaving it in the line. Let's see, we still got some. We're almost there. But we're just recovering all that refrigerant back into the compressor, the liquid stuff, because that's a lot of buildup of refrigerant. I'm using these quick connects here, which allow the shuts off right there as soon as you disconnect the line. It's very quick, very fast. Hence the name, Quick Connect. Anyway, our pressures look like they've equalized. We'll turn this off and give it a look. Just a tiny bit more in the high side there. We'll draw that over. Once that's done, we're ready to disconnect our low side line, and we can go ahead and disconnect the refrigerant line. Okay, so that's ready now. We'll be able to disconnect our low side line. Put our cap back on, making sure our O-ring's in there. And once you're finished charging here, it's a good idea to check all these points with a leak test, either an electronic detector or a bubble test. Make sure you have no leaks from your Schrader valve caps, your service lines, or even the service caps here. It's also good to check. Anyway, now we can disconnect our refrigerant. And unless you're going to charge another system, you want to avoid leaving any refrigerant in the lines here. So what we'll do is we'll go ahead and purge the refrigerant. I'm done, hopefully not another one today. We'll release the rest of the refrigerant that's in there to keep it from being trapped in the lines. And we're good to go there. Just gotta put all my stuff away, but anyway, that's how to charge a unit. The line's feeling nice and chilly right here. You can see it sweating a little bit. And it's pretty hot today. Not super hot, not as hot as it's been. Maybe 87 today. We're good to go. Air conditioning, cooling things off, nice and chilly. Good to go.